Yes, sir.
Okay, sige. So, please turn on your cameras. This morning, we will be talking na-discuss ba ko na yung average reading sa class?
Wala, sir.
Wala, no? So, kani siya is formula ra ni sa class. So, average shearing stress at the bottom of a channel. So, for example, natay channel dira, no? Na mo flow nga tubig. So, this channel experiences shearing stress, no? Sa tau, where tau is, no? Hydraulic radius and the slope. So, in some textbooks, okay, so same na siya class. So we will go to the alternate stages of flow. So, for example, natay channel dire, kani siya, no? Channel. As you can see, class, we have here a depth of the water, D, and we also have H as the specific energy. Now, specific energy is the energy at the cross of an open channel flow with respect to the channel bed. Now, since with respect to the channel bed, you can see nga tuwang H or the total energy sa kanisiya nga setup is D plus V squared over 2G. Where V squared over 2G is our velocity of approach. No, naman na energy gap mo ng velocity. Okay? If we try to solve V, no, in terms of this equation, we will get this one. H is equals to square root of 2G H minus D. And if we try to get Q, add again po tag A. So, mo na siya H is equals to A square root of 2G H minus D. Now, if you use this equation to plot the graph, kaning nasa right side, so as you can see, at D is equal to 0, kanidire, Q is equals to 0. That Q is equal to 0. Now, as you can see, there are 2 points, no? At which the discharge, at which any given discharge will flow with the same energy content. Also, na do ako points. So these depths are what we call the alternate stages, no? Corresponding 2 points na ay discharge na flow with the same energy content. Ito maning ang mga stages. So first, we have the upper stage or known as the tranquil stage. So when we say tranquil stage, meaning kalma ang data. So since kalma man, the Froude number Fn, or sometimes written as N sub F, is less than 1. For lower stage or the rapid stage, Fn is greater than 1, where the Froude number is calculated as the mean velocity over the square root of G times L. Okay? Now, for a rectangular L as a depth of flow D, therefore, atong formula may muna siya square root of GD. Okay? Now, transitions class, natay 3 main types of flows, no? So first, we have the critical flow where the Froude number is equal to 1. Supercritical flow is greater than 1. So we can also say a supercritical flow is also a rapid flow. Okay? Greater than 1 man yung Froude number. No? And subcritical flow, we can also say that this is a tranquil flow. Okay? Now, the critical depth is again depth at which for a given total head, the discharge is maximum, and for a given flow, the specific energy is minimum. Diba? I believe na pa-flash ako ninyo sa una. So, if you try to take a sample ng section width, this one with area A, differential, if you take a differential strip, dA, with differential height dD, no? So, using this equation class, H is equals to V squared over 2G plus D, our specific energy, we can arrive at the general equation. So this is the general equation for getting the clearance of any section. Okay, where Q is the flow rate, AC is the critical area, and BC is the critical width. By the way, class, when you say critical width, we're talking about the top width. So, kanera siya, no? Top width. Ha? Ang B is the top width. Dili bottom, dili side, so top width. So we also have the critical velocity for irregular channels. We have Vc is equals to square root of Ga over B. Okay, so unsa may importance sa kaning ano, critical depth. So again, by definition, this is the depth at which the specific energy is at a minimum for a given discharge. Number two, critical depth helps us identify kung unsa nga klase sa flow, may it be subcritical, critical, or supercritical. And lastly, for practical applications, it can help ensure that the flow remains stable and avoid issues such as standing waves and hydraulic jumps. Okay, so na ko ipakita nga ba nga video class showing you the different behaviors no sa corresponding to different types of flows. Ako sa i-share ha. So here we are represented here by this mura allows water to flow over it. No, natas sa critical flow or the transition flow, supercritical flow. You will notice later on okay, so muna si hydraulic jump class. So hydraulic jump occurs type of flow, no? From low to or subcritical to critical flow. So at least nala mo yung murag visualization ba kung sa ding different types of flow. Wow. Okay. Now, rectangular channels class, we have this following over G. By the way, before I forget, kaning Q, this flow rate per meter Q is different from small q. Is the flow rate so that is small kinetic energy and we have the hydraulic depth. Sa tuang general equation ganiha kani siya q squared over g is equal to a cubed over b. So kaninding a over b, this is our hydraulic depth. Okay, so those are the formulas for a rectangular channel. Now let's go to the trapezoidal channel. So any other section class nga dili rectangular, then we use the general equation q squared over g and a cubed over b. Okay, so natay critical velocity, natay critical slope. Also have the specific energy and the hydraulic depth. So same ra gyapon sa rectangular. Then we have for triangular channels. Again, if dili rectangle, kani yung general equation atong gamiton. Critical velocity and critical slope is the same. For the specific energy and hydraulic depth, the same ra gyapon. Lastly, for circular channels, we have the critical depth, kana siya, critical velocity, critical slope, Okay? Natay questions class regarding sa mga equations or formulas. Wala ra. So, let's have a sample problem. Sige, let's have a sample problem. Let's say we are to find the critical depth for a rectangular section where we are given a small q of 1.6. Sige, so how do we find the what's this? The critical depth for the section class?
Asi sa formula, sir.
Sige, so itong formula to gamiton.
Critical depth is equal to cube root of small q squared over g.
So substituting, we simply get over 9.81. So pila ni siya class?
Wait lang, sir. Ano susunod?
0.64.
0.64. It's a unit. Meters, no? Again, we're talking about depth, no? Now, some textbooks class, they use DC for critical depth. Na iban mo, so what sila YC, no? Critical depth, but same regular para siya. Okay, good. Now, let's go to another problem. So, let's try to find the critical depth for a triangular na po section. So, we're given Q is equals to 0.4 cubic meters per second. And then ato triangle is kani siya. Okay, so this is our T. Then the included angle is 60 degrees.
So, ang makadawat karon ba? Ang kadawat karon mo sa perma karon dito rin, mas lagi. So, ang video na ma, kasi kung ikaw may ito yung
Sige class, ang sama nito pag-solve.
Given niya po sa formula, sir.
Sige, saan na formula to gamiton?
Answer, q squared over g is equal to area cube over b.
Or basically in this case, we use T. Okay, we're talking about the top width.
Yes.
So atong problema there is we need to get A and T. Okay, Q and G is given. Okay, so if we rearrange the equation, this will squared T over G A cube. Okay, so let's find T. How do we find T?
Yan ang si asawa ko, pag Ford na. Yan pa rin. It's like Velos from.
Long-term plan mo.
It's like Velos.
Hybrid?
Oh, hybrid din ah. Dapat it doesn't have a cube.
So,
My favorite cube. Isa na, nalagdat ko sa trabaho.
Is that all?
Is equal to DC over 2.
Ano bang cube sa mga ganun?
DC over 2? Ano?
Ay, dili sir.
Oh, saan to?
Ang T is 4 DC sir.
4 DC?
Ikaw ba? Ito din mo ba?
Gano'n mo ng 4 DC?
Nahula sa formula sir. Ako yung screenshot.
Wow!
Oh ba? Ah, sige. If wala yung formula, how do we solve this one? Ah, sige, ato i-check. If 4 DC, pila man ni siya? Kana? Ay, wow, lagi. Wa pa man tayo DC. Rita ka solve. So, how do we get T man? This is just trigo class. So, na to pag trigo.
2y tan 30.
2y.
Tangent, sir.
So, tangent 30 sa taon na. Tangent 30. Atong
Y
goal
over
dire,
2. 3 over 2 over y.
atong goal dire is makuha ni siyang t, but we will get t in terms of y. Therefore, natay y dire. Since duha man ka buok, then we multiply 2. Okay? Ito na yung butang. Sayop na input. Dire lang. 2 times y tan 30. Kailan ni siya class? In terms of y.
1.154, sir.
1.154y. Okay? Now, nanatay t, then how do we get the area of a triangle? Yeah, sa triangle class.
1 of D8, sir. 0.577, sir. Ang area.
1/2 base. Atong base dire isang t. So, nanamtay t nga 1.154. Ato na lang substitute. 54y times sa h nga y. Therefore, atong answer should be in y squared. So, pila ni siya?
0.577 y squared.
Okay. Now, naana tayong mga a ug t. Therefore, ato na substitute. So, this becomes 0.4 squared over 9.81 is equal to 0.577 cube over 1.154y. Pa din yung y squared din. So, shift solve for y. Pila tong y class? Pila tong answer class sa y na to?
0.0326.
0.326? Ay, lagi ako ha.
0.0, sir. 0.0326.
0, okay. Na-cube man kanin yung A. Inyo ni na-cube?
Ay, sir, agree, sir.
That's it. Na-cube din ninyong A. Kasi malimtan ha, A cube di ani siya. Kani class itong answer, 0.0326. Nailan answer?
0.628, sir.
0.62. Yes, this is the answer, no? Same answer, no? Ay mo kalimutan, kani sa Q squared o A cube. Okay, so humana ta sa triangle. Now let's go to what's that? Next question, taganing problem. Again, kaniha ato ra ning gitry go, so you can use tangent 30 or tangent 60. Tangent 30 man ta din ato ra sing times 2. Okay. Now let's go to another problem. Let's find the critical depth for a trapezoidal section. Button talag Q is 8.5 cubic meters per second, and then given tag bottom width 2.5, and then atong theta sa iyang sides is 45 degrees. Sige. How do we solve this one?
Layuan sa humane ang supply ka. Dipit ka sa anong nag-humane siya.
Sige class, how do we solve this one, man? Sige, ako na lang ibutang answer class kay naikuan. Na-delivery na abot, and then na bagong equipment ang atong laboratory. Yay! So, natay bagong equipment. We have the kuan, falling head permeability test. Yay! May na lang. Sige, ako na ibutang ang answer, ha? So, pila tong answer dire? Di na ako ibutang, kamo na lang solve. Okay? So, kana siya. Anyways, interested lang mo kani class, if interested lang mo kay you can also solve this one, no? So, may nang mag-solve mo ni para ma-practice mo daan para sa inyong finals. Okay? So, the channel cross-section shown as a critical slope of kana, and then water flows at a rate of 16.5. So, you have to find the following: critical depth, critical velocity, and the coefficient of roughness. So, how do we do this one? So, again, naramon tayo multiple, same na gihapon, but ato address na lang tayo composite nga area, nga section. So, sa ribuhaton, ato nang i-add mga area. Okay, so if interested lang mo, so you can do this as your practice problem. Okay? So diri na sa takutob class kinasakoy ko ano ate manon nga kaning delivery para sa laboratory. So if you don't have any more questions, have any questions? Miss Agarin.
So, ang pipe network, sir, average kapon sa finals or dili na?
What do you mean pipe networks? Ako ang regarding sa pipe networks, ako rin siyang i-try og appeal sa atong incoming last discussion no if napatay last discussion or I could possibly hatag lang kog notes.
Oh, thank you.
Sige. Mas importante class katong nasa course outline at least studyhin lang gyud ninyo katong mga topics nga covered. Okay, kay mohatag naman sa kog final nga coverage sa atong one exam. Okay. So if there are no more questions, kana nasa. So goodbye everyone and thank you.
Yes, sir.
Thank you, sir.
Thank you, sir. Bye, sir.
Mana, sir? Mana?